Hello, everyone. Welcome to our Capstone project. I'm Christy Moncrief, and my colleague Scott Reed are here together, and we are excited to present you our project on grant characterization. So our project combines supervised and unsupervised learning to tackle the challenge of grant discovery and categorization more effectively. Research teams and administrators struggle to identify relevant grants efficiently due to overwhelming data volume, and so we wanted to find a more effective way to handle this problem. We developed a dual model system using BERTopic and a scratch-built RNN model to tackle this challenge. The idea is that combining these approaches enhances efficiency by automating discovery and categorization, thus simplifying the whole process. BERTopic offers interpretability through thematic clustering, while the RNN ensures structured and accurate categorization. Together, they improve grant discoverability by blending the strengths of both methods. So we started with a data set from Kaggle, which included grant titles, categories, funding amounts, and eligibility criteria. In future iterations, we would like to incorporate API data from National Institute of Health, the National Science Foundation, and others for a broader and more dynamic application. We had the standard challenges associated with this sort of problem, including missing values, text standardization, and inconsistent numerical data. Extensive cleaning was necessary to prepare the dataset for our machine learning models. The dataset's diversity provided a rich potential for modeling, but there were category imbalances where some were overrepresented and others were underrepresented, and that required careful attention. This was key to ensuring both the RNN and BERTopic models performed well across all grant categories. As I previously mentioned, we used two approaches to classify these grants, a supervised RNN model and an unsupervised BERTopic model. We started with data preprocessing, including tokenization, grant titles, and encoding categories. The RNN model uses labeled data with embedding and LSTM layers to classify grant titles into 26 predefined categories. On the other side of the equation, BERTopic clusters grants based on semantic similarities, leveraging BERT embeddings, UMAP for dimensionality reduction, and HDBScan for clustering. To link BERTopic clusters with RNN categories, we computed cosine similarity between topic keywords and category labels. This allowed us to analyze where the models overlap, where they diverge, and how their strengths complement each other. Now I'm going to pass the presentation over to my colleague Scott to discuss our models and some of our results.
Thanks, Christy. This is Scott Reed. For this project, we built our RNN model from scratch with the goal of processing grant titles for precise categorization. The key components included an embedding layer for text vectorization, an LSTM layer for capturing sequential dependencies, and dense layers for classification. Dropout layers and L2 regularization helped to reduce overfitting, while early stopping prevented unnecessary epochs. The model achieves strong performance, especially for common grant categories like health and science and technology. Those structured predictions aligned well with our predefined categories. However, challenges like overfitting and class imbalance impacted the less common categories. The RNN strength lied in its ability to align grants with specific research priorities, providing structured outputs critical for precise classification tasks. Our BERT model provided thematic clustering of grants by leveraging BERT embeddings to capture semantic relationships. It uses UMAP to reduce dimensionality and HDBScan to cluster similar grants. Thematic insights are mapped to RNN categories using cosine similarity between topic keywords and predefined labels. Outputs include broad interpretable themes like healthcare or sustainability. While useful for exploratory analysis, BERTopic's clustering lacks the granularity needed for accurate classification. Some clusters dominate, leaving minor categories underrepresented. Despite these limitations, BERTopic's interpretability complements the RNN, offering a dual perspective, thematic exploration, and structured categorization. For the model comparison, the RNN and BERTopic models were compared using overlap analysis, confusion matrices, and per category performance. The RNN excelled at structured classification, achieving high accuracy for dominant categories. BERTopic provided broader insights, but struggled with alignment to predefined labels. Mismatches often occurred in underrepresented categories, highlighting the need for improving mapping techniques. Error analysis revealed that BERTopic was better suited for exploratory tasks, while the RNN is optimal for exact alignment. Virtual tools like heat maps showcase the overlaps and divergences, offering insights into areas where the models complement and differ. These analyses confirm the complementary strengths of the two approaches. For some of our results, samples from the models illustrate their respective strengths. The RNN provided accurate classifications for titles like improving healthcare access in rural areas, health, and research on renewable energy technologies, which was classified into science and technology. BERTopic clustered grants into thematic groups but struggled to consistently align with the RNN categories. Examples show incongruencies in specific categories like climate resilience research funding, where the BERTopic was predicted as unknown. These discrepancies highlight challenges in aligning unsupervised clusters with supervised labels. Despite this, both models performed well in their domains, the RNN for precision and BERTopic for thematic exploration. Thanks. I'm going to hand it back over to Christy now.
Awesome. Thanks, Scott. Okay, so challenges and next steps. While this project was successful, we did face several challenges, including imbalanced data sets and the inherent limitations of BERTopic as an unsupervised tool, as well as overfitting in the RNN model. To address these in the future, we will apply techniques to balance class representation, which will hopefully enhance BERTopic's ability to map clusters to predefined categories. In future iterations, we will also shift our focus to deploying an interactive Tableau dashboard, incorporating real-time data from APIs, and exploring hybrid approaches that combine BERTopic's interpretability with the RNN's precision. User feedback will play a critical role in shaping future iterations, ensuring the system meets real-world grant discovery needs and continues to improve its performance across diverse categories. Our project successfully demonstrated the potential of a dual model system for streamlining grant discovery. The RNN delivered structured and accurate predictions, excelling with frequent categories, while BERTopic provided thematic insights and uncovered broad clusters. Together, these models complemented each other, offering a more comprehensive approach to grant identification and class categorization. Looking ahead, we will integrate live API data, refine the hybrid model, and develop a user-friendly interface to improve accessibility. This dual model approach establishes a scalable and adaptable foundation for grant discovery, balancing the precision of supervised learning with the interpretability of unsupervised clustering. And that is what we have for our presentation today. Thank you so much for joining us. We are very happy to be here, and we hope you got something out of this presentation.